Hello everyone, this is Maurizio, editor-in-chief of embedded.com. Today I am in Nuremberg at Embedded World, showing in Nuremberg Messe, and I have the pleasure to be here with Thomas Rosteck, CSS Division President at Infineon. Hi Thomas, thanks a lot for your time. How are you?
Hey Maurizio, good to have you here.
Good. So, Embedded World, so we are running different topics. So, tell me what's new from Infineon.
This year we actually focus very much on our microcontroller and microcontroller success, the story, the system around it, and how can we help our customers to develop their system in the various applications where we can offer help. And we have also the pleasure, and we are super excited that we just have been shown as the market leader in microcontroller by Omdia. So we reached a level of 21% in microcontroller share. That's awesome, and that's what we're really proud of. So
Good.
If I would go into some details, so give you a glimpse of what we're doing. So one of the new things that we just launched is our PSOC 4 Multisense. Multisense is featuring our CapSense, capacitive sensing technology. And I can show it here in this coffee machine. Because what you basically see is, on the one hand, we have liquid sensing, and the liquid sensing is super accurate by 0.1 millimeter, so we can do this. And you can also do touch on metal, which is also a very difficult technical question. Right? So later I will also offer you a coffee, but it's not only limited to coffee machine and smart home, it's also in industry applications where sometimes some customers say they can spare the flow meter because of the accuracy. So that's the one.
Thank you so much. Have a nice day.
The second one is our PSOC Control. PSOC Control is our new family that we just launched for motor control and power conversion. So motor control, like in this robot here, for example, where every of his legs is basically featuring a motor control microcontroller in there. So that's something where we drive. And we support our customers not only with the microcontroller, but with the ecosystem, with the power conversion or motor control libraries. That's another very, very exciting thing. And to also show you the breadth of things that we are doing, the last one, let me emphasize Edge AI.
Yeah.
So Edge AI at the edge will be one of the coming features. I think that will be a capacity that everyone is needing, right? And we featuring here what we call the DEEPCRAFT models, our DEEPCRAFT toolchain. Perhaps we can show you later details. And we basically announce here our computer vision. And you can use this computer vision for industry inspection, but also in smart homes to detect objects, people, and pets, and so on. So that's the exciting piece. So that's why we're super happy to be here at the Embedded today.
Good. Any other demos that you would like to show?
Maybe we can show the vision control if you want.
Yeah, sure.
Then we do a gaming contest with you.
Okay. Okay, and here, Thomas, we have an example application with AI. So
Absolutely.
tell me more.
Yeah, absolutely. So the first thing is Edge AI runs on microcontrollers. Here we have our latest controller with this PSOC Edge, which allows for low power and low memory models that we basically can run. Right? And as I mentioned before, now we have computer vision in it. And I should just show you a simple kids game, right, which is paper, stone, scissors. And you will see by the different frames, if I hold up my hand, by the different colors of the frame, that it detects it. So if I pull up the scissors, then you see here the red frame. If I hold up the stone, it will turn yellow. And if I hold up the paper, it will turn blue. Okay? So, and this is only done again on a microcontroller, which is now very, very powerful. So how do we do this? We provide here our tool chain, our DEEPCRAFT tool chain, where customers basically can develop their own model and work with this. We also provide open source starter models with DEEPCRAFT, so that customers don't have to start from scratch, but they can basically start to use the models that we provide and go from there.
So you can use any camera in this case.
You can use any camera. It's only we taking just a picture of the camera. So what you need to use is our tool chain to develop the model, and the microcontroller, our microcontroller, to then basically finally run the model in the field.
Thank you. So, thank you, Thomas, for showing me these nice demos. So let's talk about security. Let's talk about cybersecurity. So cybersecurity threats, considering the IoT devices. So everything is connected. So it's important talking about cybersecurity. Also considering the different market, different application, automotive, industrial. So how is the approach of Infineon considering the evolving needs in terms of security, and what is the biggest challenges? What do you see something more problematic?
Right. Thank you. You see, I was when I started at Infineon 20 years ago, actually more than 20 years ago, I started in security.
Yeah.
Infineon is in security for more than 30 years, and the security needs were evolving, but not every customer or every device manufacturer was actually basically providing sufficient security for the needs, because you're right, with the increasing connectivity there is an increasing attack surface. Yep. So now what's happening is that also the governments basically came to the conclusion that they have to do something, and that's why we see regulations. And here the CRA, the Cyber Resilience Act, which was basically announced by the European Union, running through the Parliament in November, and it will become effective in December 2027. And what does it mean? It imposes on every product that will be sold in Europe and has a certain connectivity, it imposes certain security resilience, cybersecurity features here.
Yes.
And this is a difference to every other region in the world, because in here this is a mandatory requirement, while we have voluntary requirements in other parts of the world, like the US, where we have this cyber trust mark, for example. Mm-hmm. So with this now, everyone that's selling, so it's not only related to European companies, because everyone that wants to sell in Europe needs to follow this regulation. And you basically will see that many of our customers are not really aware of this. That's why we put up this wall here, if I may show you. So when I talk to many of our customers, they basically will say, I have never heard about the regulation, the CRA. I'm in consumer. What I need actually is a good authentication for my business model. And still, I need to optimize my overall cost position. I'll just give you a glimpse of what you basically can do here. And with this, I think we can help as Infineon with our knowledge to first consult the customers, but then also provide them solutions, because all our microcontroller portfolio is set up to support the customers fulfilling CIO requirements.
So the important is to provide solution to reduce time to market, and also the best security in this case, like authentication, for example.
Correct.
Okay.
You're absolutely right. And I think one of the most important thing is that not every product needs the same level of security. Yeah. It's very much depending on the functionality, on the criticality in a network and so on. That's why we also developed the scheme which is called Edge Protect, which allows the customer to pick basically the security level they need to, on the one hand, fulfill the requirements, but also to basically fulfill the needs that they have. Security will become a negative differentiator if you are not really fulfilling this.
Thank you. So let's talk about, so we are talking security, but what about post-quantum cryptography? Yeah. So what in blog we can find like PQC, okay, it's different articles, you can find this acronym. So post-quantum cryptography is becoming important, central, critical topic. So how is Infineon preparing for this transition? So what role will play post-quantum cryptography in future PSOC and edge AI applications?
So the problem of quantum computing is that with the power of the new computers, they will be able to break certain sets of algorithms. And these algorithms will have to be newly developed, and that's what's called the post-quantum algorithms now that we are working. And Infineon has been in this process of developing them, that was a worldwide effort, has been at the forefront. So we also introduced 3 of our proposals into the system. And we are super proud that in January we received the first EAL6 certification for a post-quantum algorithm implementation on a security controller. So again, Infineon is here on the forefront, and this certification was issued by the BSI, which is the Federal Agency for Information Security. So we're super proud on this one. We have been there, as I said from the beginning, but we're also not stopping there. There currently is an EU project running which is dealing with post-quantum algorithms on travel documents. Because especially travel documents have a long lifetime, so 10 years, as you know, for your passport. And this will be in reach for quantum computers. Quantum computers are not there yet, at least not publicly available to hackers, I would say. But this will change over time. Some say it will be in 8 years, some say it will be in 15 years. Whatever it is, there are applications that live longer than this time, and we have to start now to protect them. And that's where we heavily engaged in.
Thank you, Thomas. So just last one question, so last one comment. So I would like if you can, which is takeaways that you would like to leave with our audience, talking about cybersecurity, security for the next year, looking forward?
So I think I would like to combine 2 things. So the one is we are now leader in microcontroller, and our microcontrollers are prepared to provide cybersecurity resilience to our customers. We will help you to kind of make your products secure and also CRA ready. And I think that's what we're really striving forward, because security is clearly in the DNA of Infineon.
Thank you, Thomas. Thanks a lot for your time. Have a good show at Embedded World.
It was a pleasure. Thanks a lot.
Thank you. Stay tuned.